Hello everyone. Now, in today's experiment, we are going to learn about the series connection while applying the Ohm's law for the resistors. So, like in the previous experiment, we are going to employ the NILVs, the basic infrastructure provided by the LabVIEW, and a few LEDs and resistors to understand how the current gets dissipated in the set of resistors which are connected in parallel to the same power supply. We have three sets of resistors connected in parallel to the single power supply. Now, as you can see, there is a single power supply which is a variable power supply and a set of LEDs. Now, before even connecting to the set of LEDs, we have connected it to an ammeter here. So these two connections are the ammeter connections, which first try to measure the maximum current that passes through the circuit, and from the ammeter we connected the lines to three LEDs. Which are in series with a 2.2 kilo ohm resistor, a 4.4 kilo ohm resistor, and a 6.6 kilo ohm resistor, and the other terminals of the series of resistor is again connected to the earth or the second end of the variable power supply. Now, as you can see here on the prototyping board, there is one 2.2 kilo ohm connected in series with a LED. There are two 2.0 kilo ohm in series which are connected to another LED which consists of 4.4 kilo ohm, and there are three 2.2 kilo ohm resistors which are in series forming a 6.6 kilo ohm resistance, which are again in series with an LED. So for a given voltage V, we will observe that the current through the paths to each resistors or through each LED I1 and I2 and I3 will be different. So for a fixed V1, we will find that I1 is greater than I2 is greater than I3. This is the current division that happens in the parallel connections. Since the resistance of each path is different, we will find that the current in each path also to be different. Now, for demonstrating that the current division in these three branches are different when they are actually having same amount of resistors in each path, we have connected LED 1, LED 2 and LED 3. Now, this is the first LED, this is the second LED, and this is the third LED corresponding to the LED shown in the circuit diagram on the figure here. So when we provide the power supply or we provide the voltage to the entire circuit, we will observe that since current through the LED 1 is greater than the current through the LED 2, we will find that the illumination of LED 1 to be greater than illumination of LED 2, and illumination of LED 2 is greater than illumination of LED 3, and the total current through the circuit I, which is nothing but I is equal to I1 plus I2 plus I3, will increase as we increase the voltage, and V by I will be equal to 2.2 kilo ohm parallel 4.4 kilo ohm parallel 6.6 kilo ohm. So now we will provide the power supply to the entire circuit and verify the functionality of the same. Now, as you can see in the computer screen here on the left, you will find two windows. One is meant for variable power supply, that is in the left, and there is a digital multimeter window which is in ampere mode. Now we will control the amount of voltage we are providing to the entire circuit while measuring the amperes or measuring the amount of current passing through the circuit. So as I increase the voltage, you can see that the three LEDs started glowing, and you are observing that the LED 1 here in the circuit is glowing little brighter than LED 2. On the other hand, you will see LED 3 not glowing at all, or relatively are glowing most dimmer of all the three. So as I increase the voltage, you can see the brightness increasing in 3 different levels for each LED, and you can see also the current is increasing slowly with respect to increase in voltage. So because of the using this experiment, we understood that if we have a voltage source connected to parallel set of resistors, the current always takes the least resistance path, or other way of putting it is, the current passes least in the high resistance path. So the high resistance path is 6.6 kilo ohm resistor series, and you can see that the LED 3 here is glowing dimmer than the rest.